My project is predicting stroke risk with machine learning. This presentation outlines my machine learning project aimed at predicting stroke likelihood in patients. I'll cover the problem, solution methodology, and key findings. What project achievements? Multiple models evaluated. I will compare logistic regression, decision tree, and naive Bayes theorem. I will use performance metrics utilized, used accuracy, F1 score, and confusion metrics. Also, optimal model identified, like selected best model for stroke risk detection, and actionable insights gained, like informed healthcare decisions from patient data. Why stroke prediction is crucial? Because leading cause of death, stroke is major global health burden. Also early intervention, because timely treatment prevents serious outcomes. And ML for high risk efficiently identifies vulnerable individuals. Problem type of my project is classification. This project addresses a classification problem. The model predicts a binary outcome, whether a patient will have a stroke 1 or not. Have not stroke means 0. This is different from regression, which is used to predict continuous numerical values, percentage. The model's output directly categorizes patients into risk groups, enabling clear and actionable medical responses. So I have two classified categories, no stroke and stroke. No stroke is 0, stroke is 1. I downloaded my dataset from Kaggle. In the dataset, 5,110 patient entries. Features, there are 12 columns with different features like age, gender, glucose level, BMI, and more. Purpose is provide diverse health and demographic data. My target variable in this data set is stroke. Stroke column is my dependent variable. Key features of what I utilized in the data set, like age, gender, hypertension, heart disease, ever married, work type, residence type, average glucose level, BMI, smoking status. These features are crucial for predicting stroke likelihood. I used 3 models, logistic regression, decision tree, and naive Bayes. Logistic regression used for binary classification, strong baseline, decision tree for interpretable, handle complex relationships, and naive Bayes probabilistic classifier, simpler assumption. Now we go to the notebook. Okay. I used these all libraries for 3 models and for data visualization to represent each model. Then I loaded dataset, then did data exploration. So this code shows how many rows and 12 columns. So info, used info, then I checked is null if my data set missing some values. So BMI missing 201 values. Then I used count plot just for stroke. Stroke is my target variable. So we can see blue is no stroke, one orange is people with stroke. So most of people have not stroke. Then I used hist plot for each feature, so we can see stroke. People who is older, they have a stroke mostly than younger people. Then I started do data pre-processing. So I dropped ID column because this is insignificant feature. Then we can see no ID column. Then I handled missing values for BMI column. Then I used bar plot. Here's Y and X axis, so work type and stroke, so we can see how many people have stroke in private, self-employment, self-employed area, government job, never worked, and children. Also, I used same bar plot for to check for information for people who smoke or doesn't smoke. So this bar plot shows the mean of the stroke column for each smoking category, how many smokers had strokes versus non-smokers. Okay, then I used correlation matrix. This heat map correlation matrix shows the correlation between all numerical features. It helps identify which variables are positively or negatively related to each other and to the target variable stroke. Strong correlation can suggest useful predictors of potential multicollinearity. Then I did split and scale features, preparing for 3 models to train models. First model, logistic regression model. So I train it, make prediction, calculate accuracy and F1 score. Here confusion matrix show for logistic regression. Confusion matrix, this table that shows correct and incorrect predictions, helping us see how well the model identifies each class. So we can see true positives, true negatives, false positives, and false negatives in each confusion matrix. I will show later for second and third my models. Next, decision tree model. I did same steps for making prediction, for calculation accuracy and F1 score. This is my confusion matrix. Third model, naive Bayes model. Also, I made similar steps. This is my confusion matrix. In this project, I built machine learning models to predict whether a person is at risk of having a stroke. I tested 3 models and found that logistic regression gave the best result based on the F1 score, which is important for finding actual stroke cases. This shows how machine learning can help doctors detect stroke risk early and make better decisions for patient care. So this is my model performance summary. You can see logistic regression. This is accuracy, F1 score, also decision tree accuracy, F1 score, and naive Bayes accuracy and F1 score. So logistic regression achieved the best F1 score, indicating superior balance between precision and recall for stroke prediction. Thank you so much.